problem on the test will be to talk about moving the exponential graph around on the xy coordinate plane. Sorry, talking for a minute. In this case, we have f of x equal to 4 raised to the x minus 4. The parent function here is 4 raised to the x power, which is very similar to e raised to the x power. E is what number again? 2.7 something. So 4 raised to the x power is going to look very much like it. It's going to go to the point 0, 1. It's going to grow exponentially really fast. As a matter of fact, when x equals to 1, 4 to the 1 equals to 4. 1, 2, 3, 4. So we're already there, and it's going to climb like this pretty quickly. That's 4 to the x. Now, you remember from our studies of transformations of functions that when you have a parentheses around the x like this is the horizontal translation. And it's that, what word again? Counterintuitive. So it's going to go which direction? Into the positives, because it goes exactly opposite of what it says in here. So this whole function that I just drew is going to be pushed over that way by 4. So if I do that, I go 1, 2, 3, 4 here, and 1, 2, 3, 4 here. I use these points, I can get this pretty easily. And that should be the answer like on A. And of course, if you don't know any of that, remember, I'm not teaching you guys too much of the graphing of the exponential function right now because you're going to use it more in Calc 1 if you get that far or decide you want to go that far in mathematics. And at that point, whoever your teacher is will reteach you how to graph the exponentials anyways. So I just want you familiar with it. And of course, have this in front of you. You should use it. 4 raised to the quantity x minus 4 hit 2.6. If you can't do it yourself, well then just read it off the screen, okay? Let's see, what picture does that look like? Maybe A. So you can expect to see one of these on the test. If you get it wrong, there's nothing more I can say to you. Okay. I can't help you anymore. Okay. Any questions? It would be nice to think that you could graph one of these things without the calculator. And you can certainly see where, before the calculator was widely used the way it is, that the graphing techniques of translation were pretty important. You know, technology has issued in an age where you don't necessarily need to be that good at drawing a graph anymore because everybody has a graphing calculator. My 6th grade son has a graphing calculator, and he can show you what this graph looks like just as fast as anybody here. So I don't think that they'll be doing a whole lot of hand graphing in the future, other than the fact, though, you still need to have some knowledge of what it looks like. And if your batteries die, what are you going to do? Cheat. Borrow your friend's calculator, right?
All right.
Or have a set
Second guess.
backup. Or perhaps rely on your own brain. Well, no, that might be too much to ask. Okay. So, with that said, let's get rid of that page. Let's see. The next question, though, those you can answer by yourself. I don't want to bog you down with those. Let's go down to do one of the convertings. So how about number 7? Number 7. E to the minus 7 equals to t. Can you convert that into a logarithmic equation? Well, you would say log base e. Remember, this number over here is the exponent. I didn't have a t in here. This says e to the minus 7 equals t when you follow that little curvy motion that we came up with. And then we know something about log base e. What is that called? That is the natural log of t is equal to -7. And that would probably be a. Don't forget natural log and log base e is the same thing. Kind of funky looking e right there. Okay. So I'll leave you with a couple of those to work with. Now we can do the same thing to convert, this is number 9. The natural log of that 46 equals 3.8286. Convert this into an exponential equation. What do you get? Well, it might be better to write the log ln as log base e, and then do that motion like this. And say e raised to 3.8286 is equal to 46. Do you think that's true? 3.8286. I'm not going to hit enter just yet. I'm thinking it's going to be equal to 45 point something. What do you think? Yeah. So really, this should not say equals. It should say approximately. For all practical purposes, that's 46, right? All right, so I'll let you do some of those. We need to solve this one, number 11. Here's an actual equation. Log base 8, that's not a typo. Almost looks like 2 G's, doesn't it? Oh. What's the first thing to do here? Seeing as you'll be taking the test on Tuesday, I don't want everybody to answer at once. So, what's the first thing to do here? Can you throw your pencil at it? Does that? Come on, what do you do? Somebody knows. Listen, I talk in front of people all the time. It's really not that hard to speak in front of people, so just go ahead and blurt it out. What's the first move?
Convert it.
Convert it, thank you. Convert it over to an exponential equation. By using this, we learned so many times, 8 to the 1/3 is equal to the square root of x minus 5. What is 8 to the 1/3? That's the same thing as the cube root of 8. What is the cube root of 8? 2 times 2 times 2 equals 8, so the cube root of 8 is 2, is equal to the square root of x minus 5. Squaring both sides, you get 4 is equal to x minus 5, so therefore x equals to 9.
Of course.
We can check it out. What is 9 minus 5? That's 4. The square root of 4 is 2. 8 to the 1/3 equals 2. There is something to be considered about here. We checked it. When you square both sides of equations, you remember you can also get those erroneous answers? I've talked about that in the intermediate algebra class a bunch and probably mentioned it. Anytime you square both sides of an equation, it is worth noting that you can take something like the square root of x equal to minus 2, which is a false statement. This is not true. There is no square root of x that equals to minus 2. Square roots are always positive, right? Unless you put a negative out front. But if you square both sides, you get x equals to 4. And that is possible, right? So by squaring both sides here, you take a false statement and make it a true statement. Well, that tells you that when you square both sides in an equation, that you may have said something that didn't have a solution and now make it have a solution. Which means you should really check your answers when you square both sides, because it might not work. Even though squaring both sides is kind of a legitimate operation in mathematics, the result may or may not work. So you might want to double check. Of course, then people say, well, shouldn't you check every answer? And I say, yeah. But I would be lying if I said I checked every answer I ever got. Sometimes checking the answer is harder than the actual problem. So